So continuing on with derivatives, of course we learned this fancy word in the last section, differentiation. Ooh, we feel so smart, don't we? Means that we're finding a derivative, and in the last section we looked at two different definitions for derivative. One is where we were calling that distance between our 2 points h, and one is where we were calling the distance between our 2 points delta x. I'll suspect you probably need to pause the video and copy these down. So, other than that, they are the same definition. Okay, so pause the video and write that down. And now we're going to throw one more version of that definition at you, which is, if I'm trying to find the slope, I'm looking at the limit as x approaches c. So in other words, x is getting closer and closer back to this value, so the distance between my 2 points would get smaller and smaller because they'd be coming the same point. And so I would be doing f of x minus f of c over x minus c. And you should see how that should make sense, because you have f of x, there's your y value, minus your y value over your x value minus your x value. So just a different version, and you will see all three of these. They will interchange them, and who knows which one they'll give you on the AP test, so you must be prepared. Okay, so these are really important. That's why they have asterisks. So if a function is differentiable at x equals c, then it is continuous. So therefore, differentiability implies continuity. But it does not work the other way around. It's possible for a function to be continuous and not differentiable. So continuity does not imply differentiability, and here's why. If I have, let's say, an absolute value graph looking like this, it is continuous. I did not lift my pencil, notice, but it is not differentiable at the cusp. So continuous does not mean it's differentiable. Okay, so now we got to figure out what the little secret is, what they've done here, what our f of x is. So when I look at this first one, remember my definition is f of x plus h minus f of x all over h, and I'm taking the limit as h approaches 0. So when I look at this first one, I go, ooh, x plus h. Oh, that's this crazy stuff, f of x plus h. So let's see, what's happening to it? Well, it looks like this is where the x should be. So that would be x plus h, and oh, I'm raising it to the 10th. So I'm thinking that f of x is really x to the 10th, because f of x plus h would be, sorry, that I meant to make that a 10. I said 10, did you hear me? I did say 10. So this would be x plus h to the 10th. And then they've used some value to plug in for x. Well, what does it look like they plugged in for x? Up in here, looks like they used x equals 1. And so therefore, because it says at some number c, so it looks like that number c is 1. And then I can just double check it, because this should be x to the 10th. Well, x is 1, so 1 to the 10th would be 1. Oh, that works. So I know that c is 1. And my function was f of x equals x to the 10th. Let's try another one.